So hello to everybody in the audience. My name is Markus and this is the agenda of today. So I'll be starting with explaining the context of today's topic. So what are blood products and what's blood plasma fractionation. Then we'll focus on one of the fractionation, the downstream processing method in the blood plasma fractionation, which is the ultrafiltration. And then we will get into the, let's say, Vaisala's territory, which is measurements. So I'll first introduce briefly the, let's say, the current de facto protein determination methods, and I'll be explaining why refractometers actually could be replacing those two methods, and then finally focusing on the refractometers and a couple of beneficial features we have. First key point is that I want you to take away from this webinar is that refractometers can determine protein concentration. So we can replace the Kjeldahl and the Dumas methods with the refractometric protein concentration measurement. And on the figure on the left, you can see how excellently the refractometric concentration relates to the how excellent the agreement is between the refractometric and the Dumas method. The graph there is about immunoglobulin G, but there are publications basically proving similar thing about albumin. And the second important point about refractometric protein concentration measurement is the temperature. I think it was also mentioned in these articles that as stable as possible, the temperature is very important when you need to achieve very accurate refractometric concentration measurements. And we in Vaisala do not have laboratory refractometers in our offering. Lab refractometers can actually achieve better results than inline refractometers, because in the lab you can thermostatize the sample and that way actually measure and control the temperature of the sample very accurately. However, if you need to measure inline, you have to have an inline instrument, and in that case, Vaisala does have offering, and please consider us when thinking of inline refractometers for this application. So as stable as possible temperature is important to achieve the best results. And third important point for refractometric measurement is the calibration for the protein concentration. So there is this need for standardizing the D and DC value. The D and DC means the sensitivity or the slope between the refractive index and the protein concentration. And I think there are different publications that state different D and DC values, and this variation between the values comes from, I think, simply the fact that blood plasma is not homogeneous liquid. It depends on the batch, on the exact number of, or the amount of constituents in the blood on that specific batch, and for that reason there is variation between the D and DC values. But this is a matter of standardization and agreement in some sense. And this kind of variation is also present in Kjeldahl and Dumas methods. They have a similar weakness in the fact that they determine all nitrogen from the sample, whether it's from a protein or not from a protein. So also those measurement methods are prone to let's say, variation from other constituents. But refractometers can be calibrated quite flexibly, actually, and as we see, we can easily replace the current de facto nitrogen determination methods with the refractometer.